All right, everyone, this is a lesson here that is frequently tested on the AP exam, typically comes out as an FRQ. It's possible that you'll also see this as an MCQ sprinkled in there, but we call this separation of variables, all right? This is part of the differential equations part of the course, and ultimately what we're looking for here is a particular solution, okay? But it is the process of separation of variables, all right? So basically on the AP exam, what the wording that we'll see on these FRQs usually has this phrase: find the particular solution, y equals f of x, that's a function, right, to the differential equation with the given initial condition. So we're given dy dx equals something, right? And remember that dy dx is a derivative. So that's why we're given a differential equation, okay? And now our goal here is to go through the process of separation of variables. Now this to me is a moneymaker. This is a big point maker here on this FRQ, all right? And I want you to memorize this phrase here that I wrote on the top right corner: y with dy and x with dx. Okay, y with dy and x with dx. And so that's our goal as far as separation of variables. How can I get y with dy and x with dx? Well, this is an equation, all right? And so I'm just going to start by cross multiplying here. And if I do that, I'm going to get y dy equals 4x dx, right? And now, once we have this separation of variables, a lot of the times, that's usually the first point on that FRQ. Okay, so that's great to know. Followed by, can you get rid of this, dy and this dx, right? Because our goal is to find the particular solution, the function, right, the f of x. So basically, notice we're given an initial condition here in terms of y, which ultimately just means that, when x is 0, y is -5. That's just an initial condition. Sometimes they give it to us like that as well. And so what we need to do here is integrate now both sides, okay? And so by doing that here, we'll just get y squared over 2, right, which is then equals 2. And then over here, we just get 4x squared over 2. And I'm going to write here plus c, okay? So once we do that, and integrating both sides of this differential equations, sometimes they just give you 1 point for integrating both sides. A lot of the times they just give you, 1 point on each side. So it really just depends. I'm just going to go ahead and put like +1, just to keep it kind of general, okay? Just so you can kind of get an idea of how the points come together. All right, so now we find ourselves having to find c. Well, we know what x and y is, right? So we're going to go ahead and use that initial condition, right? And we know that when x is 0, y is -5. So we're going to go right up into that equation right there, okay? And that's basically just going to be, let's see, when x is 0, y is -5. So we get -5 squared over 2 equals to, let's see, 4 times 0 squared over 2, and then that's plus c, right? Okay, so I know that 0 squared, all that there is going to be 0. Okay, this gives me c. And then -5 squared, well, that's 25. And we really end up just with 25 over 2. Okay, and so we learned that c is 25 over 2. That's important, right? Remember, when you find c, you got to plug it right back into your equation. So this is y squared over 2, which is equals to 4x squared over 2 plus that 25 over 2. Okay, now by the way, I didn't add c to both sides because remember that if you add c here and then you add c here, what happens is the c's cancel out. So we do technically have a constant that we have to find because we have an initial condition, and you can see that because it's given the initial condition. So I just added it to the side that has the x, okay? Anyway, so we got that going there. And now our goal here is to find that particular solution that I underlined, y equals f of x. Basically, can you isolate y? All right, let's work on that. So if I want to work on isolating y now, I'm going to start by getting rid of this fraction, multiplying 2 to everything here on both sides. Okay, so the 2 is going to cancel with this 2, right? It's going to leave me with y squared equals, right? Over here, when I distribute the 2 on this fraction, right? Well, first of all, let's see, 4 divided by 2. I didn't even simplify that, but that's going to give us 2. But if I multiply by 2, that's going to give us 4x squared. Okay, and then over here, 2 on the top gives us 50, but 50 over 2, well, that's 25. Or you can just say, hey, I'm going to multiply the 2 and get rid of them, right? Either way, still 25. Okay, and now we got to get rid of this square to isolate y. Well, how do we do that? Well, we just take the square root, but we want to do that on both sides, right? So that the square root can cancel. We get y equals, this always is going to give us a plus or minus, right? So we end up with plus or minus that 4x squared in the square root there, plus 25. Okay, and now here's the catch. Look at your initial condition. We had that when x was 0, y was negative. So I'm going to go ahead and use the negative. So I want to just write here that y is equals to negative, and then that'll be the square root of 4x squared plus 25, right? And that's basically negative because of the initial condition there, okay, the y value. Oh, and I stopped writing points halfway in between here, didn't I? Okay, so let's see. Where do we get the point number 3? We did find C, right? And when we plugged it back in. Okay, right here. When we plugged in C, there you go. That was point number 3. All right, and then we solved for y, and then right there. If you can get to that equation, that's point number 4. But remember what I said. A lot of the times on this step, depending on the equation that you're given, the differential equations, oftentimes they'll give you a point for the left side, and then they'll also give you a point for the right side. Okay? All right, so let's go ahead and just work on a couple of examples so you can see how this works. But you can see there's a lot of points up for grabs. All right, and just making, those 4 points there could even get you to the half C's on that particular FRQ. Particular. Okay, so here we go. Let's work on this one. Our goal is to get, y with dy and x with dx, right? Okay, so I noticed that we have y already with dy. I really just got to get rid of this dx. So I can start by multiplying dx on both sides to get rid of that, right? And then I end up getting this. So it's just a little algebra, right? So we really end up with y dy equals e to the x dx. Okay, point number 1, done, right? Okay, awesome. Now we move on to how can we integrate both sides? Oh, well, we're just going to integrate on the left, integrate on the right. And this is just a power rule, right? So that's y squared over 2, which is equals to, I'll go ahead and put the c on this side. Well, that's just e to the x plus c. Okay, there's point number 2. All right, now from here, let's work on finding c. We're given an initial condition, right? And that initial condition is when x is 0, y is -4. If you want to write it over like this, absolutely, right? Whatever helps. So let's plug in our y value of -4. So I'm going to use parentheses, -4 squared over 2. And then that's equals to, let's see, when x is 0. So that's e to the 0 plus c. All right, anything to the 0 is always 1. So let's simplify this, right? -4 squared, that's going to give us 16. So that's 16 over 2, that's 8. And then if we do -1 on both sides, we end up with c equals to, let's see, 8 minus 1 should be 7. All right, so we got our c value. Let's plug that into our equation here. Okay, so we can get point number 3. That's y squared over 2 equals to e to the x, and then plus 7. Okay, we just locked in point number 3. And now we're working on solving for y. Okay, so let's get rid of that squared, right? I'm sorry, let's get rid of the denominator. Ooh. Okay, 2 here cancels with this 2. There's our y squared. All right, when we multiply 2 to this term, we're going to get 2 e to the x. And then 2 and 7, multiplying those gives us 14. Okie dokie. How do we get rid of the square? We will take a square root on both sides so that this will cancel, giving us y equals. And then remember, we have to say that's a plus or minus, right? So how do we decide between that positive or that negative? And that's where that initial condition comes into play. You notice how that y value is negative, and that's how we'll choose. So we're looking at the initial condition. We say that it's going to be negative radical 2e to the x plus 14, okay? There you go. Did I keep writing the points? Sometimes I forget to do that. I did. Okay, perfect. So this is the last point right there. All right. Looking good, right? Not so bad. But this is the process you have to follow, okay? Separation of variables. Y with dy, x with dx, right? Okay, integrate both sides. Plus c, let's put it with the x side. Okay, and then, of course, from there, find your initial, find your c using that initial condition, plugging c back in. We've done a little bit of this before. And then, of course, finding y, okay? Is it positive or is it negative? That's all based off of that initial condition. All right, so we're going to do lots of examples just to really get you ready for this, okay? This one's going to require lots of manipulation, okay? Our goal is to get y with dy and x with dx. So this one is going to require me to move this y over here to this side. So I can do that by dividing the y on both sides, right? Like this. So basically I get 1 over y, right? But I get rid of y now. And then basically I need to get this x over here to the other side. So I'm going to multiply dx so I can get rid of that. And then dx comes over here. Now this looks like a hot mess. So let's rewrite it. We get 1 over y dy equals to 3x squared dx. You can see they're getting a little bit more difficult in the separation of variables process. And the more difficult it gets, that's usually why they give you a point there, okay? All right, so that's point number 1, right? Point number 2, can we integrate both sides? Well, let's see. Do you guys remember what the integral of 1 over y is? That should be ln of y, right? Which is equals to, now this is just a power rule, right? And that's 3x cubed over 3 plus c there. And again, you can see that they're getting a little bit trickier. So the more nasty it is on the left and on the right, that's when you can usually see that extra point up for grabs, okay? All right, so let's keep adding these points, right? We got 1 point there. And then we keep moving. Oh, by the way, these 3's, we can cancel them out, right? Let's keep it simple. Okay, now that we got an x and a y, we're ready to find that c value. So we'll go and use our initial condition, which is really just 0, 2. Okay, and let's see. Okay, well, y is 2. So I'm going to say here ln of 2 equals to, let's see, then we got 0 cubed plus c. Well, we know that's just going to give us 0, right? Okay, so this is really c, which is equals to ln of 2. I always keep the absolute value because let's say you have a negative. We've seen that before. That will be undefined, right? So, you know, I always try to keep that until I'm ready to go. Once we find the c value, ln of 2, that's obviously going to be a positive value, and then we can get rid of the absolute value there, okay? All right, so here we go. We got this ln of y, which is then equals to, we got this x cubed plus this ln of 2, right? We just plug that in, so point number 3, cha-ching, right? Okay, and then, you know, our goal now is to isolate this y. So what's the best way to get rid of this ln? Apply an e to both sides. All right, so we're going to exponentiate over here. We're going to exponentiate over here, which means everything else becomes a power, all right? That's how we can get rid of this right there, okay? Now, I know that there's some properties of exponents happening here, and we see e and ln, and it's kind of screaming at us. But remember, you don't have to simplify FRQs, okay? And because of that, we can leave it like this and get that full credit, okay? So anyway, y here is equals to e to the power of x cubed plus ln of 2. I'm going to leave it just like that for that last point. There we go. Remember that there are some properties that we discussed in earlier lessons. The integral of 1 over 1 plus x squared, right? That plus indicates that it's an inverse tangent. And then when we have the integral of 1 over 1 plus y squared, well, then that's still inverse tangent, except the variable of integration, dx versus dy, that'll make it tangent of x or inverse tangent of y. Some common values for tangent. Tangent of 0 equals to 0. Tangent of pi over 2, undefined. Tangent of pi over 4 is 1. Tangent of pi over 3 is radical 3. And tangent of pi over 6 is technically radical 3 over 3. And how do we get these tangent values? Remember that on the unit circle, tangent is just y over x. Okay, so that's important. But again, these are just some common values. And just because I'm going to give you some tangent questions now. All right. So remember that ultimately we're always doing y with dy and x with dx, right? Okay, so here I see that I got all this stuff here, right? Now, I can't just say, hey, I'm going to minus or subtract, let's better said. Okay, I can't just say I'm going to subtract y squared on both sides, because then I'll have like dy minus y squared. And that, well, that can't be, right? It's always, the variable of integration is always attached to the expression that we're integrating. So I instead maybe want to try to get rid of this dx. I'm going to work on multiplying that because I know that needs to go. And when I multiply dx, it looks like this, you see? But the problem here is that I haven't separated my variables. I don't have y with dy and x with dx. I got dy over here, and on the other side of the equation, there's my y. So since this whole thing is attached together as one, we're going to instead divide y squared plus 1 on both sides, okay? And meaning that this whole thing is 1 over y squared plus 1. Now this will cancel, and it really just leaves us with 1 dx, which is equals to, and then y is with dy. So there's no x, but we've separated the variables. This is a tricky one, okay? So I'm going to write it here, 1 over y squared plus 1, and then dy. So y with dy, questionable, right? X with dx. But I don't have an x on this side, so that's a good first point right there, okay? All right. Now that we're here, this looks very familiar to what I just put on the screen, right? Which is that the inverse, oh, I'm so sorry, that inverse tangent antiderivative right there, right? Okay, so there it is, and it's even in terms of y. So we want to write that this is the inverse tangent of y equals 2, and then we want to say here that if I use a power rule, and that's a constant, well, that's just going to give me x plus c, right? Okay, we got that. We got our initial condition. This time I swapped it up around for you there. So I swapped it for you. So this time I swapped it for you. So we're going to have 1, 0. All right, let's see what that looks like. Well, that means that when x is 1, y is 0. So we have the inverse tangent of 0, which is equals to 1 plus c. Hey, I just got to do minus 1 on both sides, and then I'll find my c, right? But what is the inverse tangent of 0? Remember, that's going to give us an angle, okay? When does tangent even give us 0, okay? You might remember that the tangent function, by the way, this is from your pre-cal days, but the tangent function has some restrictions, and the sine, I should actually write that over here. The sine function has some restrictions, right? And those restrictions go from negative pi over 2 to pi over 2. This is important. I should have written this. We also know that the inverse cosine has some restrictions, and that just goes from 0 to pi. There we go. And then we have that inverse tangent, which also has some restrictions, except that one goes from negative pi over 2 to pi over 2. Okay? There we go. Okay, so not inclusive, by the way. So when do we get a tangent value of 0, right? And remember, that's just taking those y over x values. So if you think about it, we're using this part of the unit circle because that's where negative pi over 2 falls, and that's also where pi over 2 falls, right? But we don't want to include these two angles, so everything else in between. All right, well, let's think about that. You know, we can take those coordinates, which is technically 0, 1, okay, and we can take this coordinate here, which is technically 0 and negative 1, and then we can take this coordinate here, which we know is 1, 0, and if we start doing y over x, the tangent value of that, 0 over 1, oh, that's just going to give us 0. So 0 over 1 is 0, right? That's that tangent value we're looking for, right? It's 0 at the angle of 0, right? And also at the angle of 2 pi, but notice that 2 pi doesn't fall within this restriction, right? So we don't usually list it as 2 pi, we usually list it as 0, all right? And that's why you see that here. So tangent of the inverse tangent of 0 is 0, okay? So I'm going to go ahead and write that as 0, and then of course when we do minus 1 on both sides, 0 minus 1 is in fact negative 1, okay? All right, so we found our c. Let's plug it in, right? So we got to plug in negative 1 over here. We get the inverse tangent of y equals x minus 1, okay? And here I go again. I forgot to write the points in. We integrated both sides. We plugged in c right there. Okie dokie. And now we are ready to solve for y. Oh my goodness, look at where y is all mixed into this mess here. Remember that if you want to get rid of the inverse tangent, all you have to do is apply a tangent, okay? So if we apply a tangent on both sides of this equation, let's see if I can move just a little part of that. Nope, The whole thing or nothing, huh? Okay, fine. If we apply a tangent to both sides of that, so that it looks like this, that's how we can get rid of that, okay? But what I do to one side, well, I want to do it to the other side, you see? Okay, and so we end up with y equals to the tangent of x minus 1, okay? That's how we can get to that particular solution, y equals f of x right there. Point number 4, if you will.